Hello students, welcome. In previous videos we have discussed covalent bonds and valency bond theory and hybridization. And what is the polar covalent bond? We know that the covalent bond is formed due to mutual sharing of electrons by two atoms. A pair of electrons is shared by two atoms. Then let us discuss few examples of covalent bond. So first, the formation of hydrogen gas. We know that hydrogen has only one electron in its s orbital, and when two hydrogens come close to each other, two hydrogens contributes each one electron. A pair of electrons is formed and this pair of electrons is shared by two hydrogens. Then here it is a single bond because two electrons, one pair only shared between two hydrogens. Similarly, let us discuss the formation of chlorine gases. We know that chlorine has 7 electrons in its outermost orbit or third orbit. So according to Lewis dot structure, chlorine has 7 electrons and second chlorine also has 7 electrons, and each chlorine contributes 1 electron and a pair of electrons is formed. This pair of electrons is mutually shared by two chlorines. So this is the bond pair electrons. Then single bond is formed between two chlorines. So in this way the chlorine gas is formed. Then what about when one hydrogen and one chlorine come close to each other? Here hydrogen, we know that first orbit, hydrogen has only one electron in its first shell and chlorine has 7 electrons in its outermost shell. Then hydrogen contributes 1 electron and chlorine also contributes 1 electron and a pair of electrons is formed. Then one bond is formed between hydrogen and chlorine and hydrogen chloride gas is formed. Then in these three chemical reactions or formation of hydrogen and chlorine and formation of HCl. Here one pair of electrons shared by two atoms. Then are these three covalent bonds are same? You can say yes, but if we observe carefully, these three covalent bonds are not same. And first two the formation of hydrogen and formation of chlorine are same. One pair of electrons shared between hydrogens and chlorines. These two are similar bonds. Then when come to the formation of hydrogen chloride, the covalent bond between hydrogen and chlorine is different and this bond is called as polar covalent bond. Why this bond between hydrogen and chlorine is different even though one pair of electron shared between hydrogen and chlorine? To know this, first we need to learn about electronegativity. Electronegativity. What is electronegativity? The nature of attracting of electrons towards one atom is known as that electronegativity. So electronegativity is a nature of the atom attracting the bond pair electrons. So here when the bond is formed between two same elements, two identical atoms, so here both have same electronegativity. So the bond pair equally attracted by the two hydrogens because the hydrogen, two hydrogens are same, so both have same electronegativity. Electronegativity is nothing but attraction of electron pairs towards it. So both have same electronegativity, so both attracts that pair of electrons equally. So next come to chlorine, formation of chlorine. Here also chlorine, two chlorines are same. So whenever the bond is formed between two chlorines, the bond pair electrons equally attracted by these two chlorines, because the electronegativity of these two chlorines are same. But whenever we come to the formation of hydrogen chloride, whenever the covalent bond is formed between two dissimilar elements, let us say here hydrogen and chlorine, here these two atoms have different electronegativity property. So when the covalent bond is formed between these two dissimilar elements, then this bond pair electrons attracted by one atom more than other atom. The atom which has greater electronegativity, and the electrons will be attracted by that atoms more than the other atoms. For here, in the hydrogen and chlorine, formation of hydrogen chloride, so here the bond is formed, and in the formation of hydrogen chloride, chlorine has high electronegativity than hydrogen. So then what happens? The chlorine attracts the electron bond pair electrons more than the hydrogens. Due to this, hydrogen slightly gets the positive charge and chlorine gets slightly negative charge. Hydrogen got positive charge. Initially hydrogen has one electron, okay, in first orbit. After formation of bond, the one single electron, it has moved towards the chlorine, because the chlorine having high electronegativity. So the hydrogen gets partial positive charge and chlorine gets one extra electrons close to it due to having high electronegativity, so it gets partially negative charge. So due to this, due to the electronegativity, two atoms in this covalent bond getting the poles positive and negative. So that's why the bond formed between two dissimilar, the covalent bond formed between two dissimilar elements is called as polar covalent bond. Okay, this is about whenever the bond is formed between two dissimilar elements, then that bond is said to be polar covalent bond, and these molecules are said to be polar covalent molecules or polar molecules. Then already in previous classes we have studied that ionic bond and covalent bond. Now we have studied polar covalent bond. Then what are the properties of these ionic bonds and covalent bonds as well as polar covalent bonds? Ionic bonds generally they are solids, because the strong electrostatic forces are present between the atoms present in the ionic bond, because the ionic bond is formed due to transfer of electrons from one atom to other atom. So the attraction, the strong attraction is present between two different charges. So ionic compounds generally in solid state, and they have high melting point and high boiling point, whereas the covalent compounds, the covalent bond is formed due to mutual sharing of electrons. So when we compare the bond strength with ionic bond, the covalent bond has very weak bond. The strength of the covalent bond is weak. So due to this, generally at room temperature, the most of the covalent compounds are gases and some are liquids, and the melting point and boiling points of the covalent compounds are very low. And polar covalent bonds, the properties of polar covalent compounds, it is in between the ionic compounds and the covalent compounds. So this is about polar covalent compounds and the properties of ionic, covalent and polar covalent compounds. Thank you.